Okay. So we started on the intelligent network. We will quickly summarize what we have been doing. We started saying that this is the network overlay. Some idea of overlay. Overlay means it is coming on top of a present network. Present network could be normal PSTN. On top of the normal PSTN, IN can come. So on top of the cellular network, IN can come. Whatever the lower level network is handling the normal telephone function, this IN is a layer which will be service oriented. It looks after the service. So new services can be created, new packages can be created on the normal network. So the whole idea was separate the network logic from service logic. That is what we did. After that we identified that it needed several technologies to implement. One of the technologies was SS7 protocol. Without SS7 we can't implement IN. So therefore we thought of studying SS7 also. That is where we are. Last time we identified the building block of IN. What was the key idea? There were XPs. What are XPs? Signaling points. There are signaling points, and signaling points are connected to the telephone exchanges, the switches. So commands to the switches and status of the switches will be going through this signaling point. And several signaling points will be connected to one signaling transfer point, which we call STP. And STPs are connected to STP, service control point. And on top of service control point, you can have service creation environment, which goes to several levels. At the top, you will have service creation environment. New services can be created by that. The new services created will be implemented on the network through STP, signal control point. So that is a summary of what we have been discussing. Okay? So today's discussion will be on the protocol layers of access level. Would you like to continue? We started the subject access level, so it will be directly the protocol stack. At the moment we have a program. It will go in a moment, but let me explain. In the SS7 protocol, you don't use the word layer, you call them levels. This is quite an advanced protocol, SS7, although not very popular like IP, it's very advanced. And we have different levels like this, and these different levels are identified by the word path. We call message transfer path, control path, application path, like that. But when you study ISO layers, you use the word layer. It's called physical layer, then data link layer, network layer, like that. You don't use the word layer now, you call it path. Because the overall job has been subdivided into parts according to SS7 design. So they call each little level as a part. So we put a sign and mention that new word. Protocol in each level are normally called part, P-A-R-T-S, part. P-A-R-T-S, write that within inverted commas. And then we will draw this protocol structure. First of all, look at it. We have at the the lower level we call message transfer part. Message transfer part level 1, message transfer part level 2, message transfer part level 3, and from there if you there it is getting divided into two. One side is going for circuit switching, other side is going for packet switching. Because these networks, telecom networks, have circuit switch part and packet switch part, both together. It's not a complete packet switching network. So protocols must support both functions, circuit switching function and packet switching. For the circuit switching, there is a part called ISUP. It is called ISDN user part. ISUP. Packet switching, there are several layers like STCP, TCAP, AP, application part, likewise. Okay. So first to understand is that there are, the power came back. First to understand that there are two sides of this protocol stack. One side is dealing with the circuit switching part application, other side is dealing with packet switching application. So we'll mention it as a sentence before drawing. So the protocol stack. Protocol stack has two columns. Stack has two columns. First up, one column support. Circuit switch application. And the other column support packet switching application. Other column support packet switching application. However, the lower three levels are common for both columns. Next paragraph. The lower three levels are involved with message transfer. Underline message transfer. Therefore, they are called MTP. In that is message transfer part. Message transfer part. MTP is divided to three levels. Divided to three levels. Level 1, 2 and 3. Level 1, 2 and 3. Following abbreviations are used. Following abbreviation, DWRE, TIA, TION, abbreviations are used. We'll summarize the words table in the protocol. One is MTTV only. Let's rewrite as this MTP, message transfer path. Message transfer path. Next one is STCC. Signaling connection control path. Signaling connection control is the job. Part is always coming in this term. Signaling connection control. Third one, sequence. Transmission capability, application path. At the top we have API, application part. At the top, application part, there are several there. There can be one application part called MAP, mobile application. OAMP, operational maintenance part. There are some other names. You can mention about two. Mobile application part, operation and maintenance. So there are application parts that can come on. Then last one, ISUP, and I stand for ISVN. Itself is a wrong word. Integrated by the visual interface. ISVN, user part. ISVN, user part. So we will draw this without writing the long words now because we have defined the long words. Just draw the two columns now. Lower three levels are common to both columns, so we draw only one. But actually there are two columns there. This is circuit switch operation, this is packet switch operation. So just write this abbreviation on STCP, TCAP, MAP like that. Don't write the details. don't write the long words. Only the entity level 1, level 2, level 3, HTTP, TCAP, and at the top AP, application part. On the other side, ISP. That's all. Details we will be writing when we describe each one, because you may be required to write short notes for these different protocols. In the past papers, very common that they ask you to write short notes on the protocol. So we write short notes, and these are the details here. And the yellow areas are mainly discussing about the application. And the blue area here is dealing with the bit level, bit transmission. This area is like switching and routing. And you can notice ISQT is a bit protocol which has the application part as well as routing part together. It is not separated. That is why the color mix cannot. But I don't think we can put the color mix there. So that it is our understanding of it. Right? So first of all, we will mention that ISQP is the circuit switch part, other one is the packet switch. You can write below this. ISQP is SQ7 application protocol. SQ7 application protocol for managing circuit switch connection. Example, telephone conversation. All your telephone connections are made by the ISQP protocol. So therefore it is a very popular, heavily used protocol. Continue with the paragraph. HTTP, correct, not HTTP, TCAP, 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 and AP, application protocol, are used for managing packet switch application. Example, what are packet switch applications you have in the internet, in the PhD? Like you can access the databases through your telephone line. A modem can access another modem and get connected to the internet. So that you need STTP, TCAP and AP. Example, accessing the database through the network. Accessing a database through the network. So it is not a normal call. It is accessing a database through the network. For that, you have to use this yellow protocol. This side it is ISQP. When you take calls, it is this protocol. When you get connected to databases via PSTN, it is this protocol. I am sure you have used all these protocols without knowing their names. Therefore, these are heavily used actually by people. Okay, if we compare this with the OSI, before we go into description, if you compare this with OSI, you find these lower two layers are directly messing with the OSI lower two layers. What are the names? OSI lower layers, this is physical layer, data link layer. But when you look at the network layer, These two together is doing the network layer job. Right? Then session layer, application layer, session layer and transport layer are not there. And this is directly the top application layer, this part. The comparison could be like this. Comparison is like this. On the right hand side you get the OSI layer, which you have studied earlier. Left side the two columns here, this is one column, this is the other. So we go through the concept. Before that you can write subheading, comparison with the OSI model. Comparison with the OSI model. What do we know? TCP level 3 and HTTP layers are handling the jobs of the network. The network layer has been subdivided into two. If you look at the normal Ethernet, we noted that this level is divided into two. What are the two here? You already know this one. The link layer was divided into two. In the diploma, what did we do?
MAC layer
and
LLC.
Right. But in this one, we don't divide. Reception protocol designers have used the same data link layer, they don't subdivide. They subdivide this one. Now you can see different implementations. Earlier we said when we discussed it in the diploma, this one is only a logical. This is only a logical framework. Okay? Whereas the other one, SS7, is not a logical framework. It is a practical implementation. Okay? So shall we make those comments now? Network layer is getting divided into two. So one comment you can write is the network layer. Network layer gets divided into two. Network layer gets divided into two. Within bracket MTP3 and STCP. MTP3 and STCP. MTP3 and STCP. First bracket. Transport, session and presentation. Transport, session and presentation. Transport, session and presentation layers are absent. Layers are absent in SS7 packet switch protocol stack. Packet switch protocol stack. So that is the comparison between the two. Sometimes you may be required to do a comparison and show it like. Now we will write small short notes about what each of these layers are doing. Basically from the bottom here, MTP level 1, what is it doing? It is dealing with the PCM time slot of the E1 line. There are lots of E1 lines joining the exchange in the PSC. Each time slot is a channel. So MTP level 1 is a protocol handling those time slots. It's directly dealing with the bits available in the E1 link. So we will write a short note with those ideas. Comparing MTP level 1. And that you can write this is the signaling digital link level. This is the signaling digital link level. Underline signaling digital link. It provides digital transmission of information. Digital transmission of information in the bit, in the form of bit. Digital transmission of information in the form of bit. Within bracket, in the TDM time slot. In the TDM time slot. TDM time slot. Each carrying is carrying 64 kilobits per second. Is carrying 64 kilobits per second. Why is that? Carrying 64 kilobits per second communication channel. Possible. Therefore, this is similar to the physical layer. Similar to the physical layer of the OSI model. Physical layer of the OSI model. So that short note is for the entity level 1. You can read it quickly. Shall we read it quickly because bit of a theory we are going to write, so we will do it part by part, small part by part. You can quickly read the idea. What are the key ideas? Key ideas is that it concerns the transmission of bits over time steps of the TGM even link. Every time step will carry how many bits? 8 bits. So all the theory we studied in the diploma for PCM multiplexing is there in the level 1. So in other words, what I am trying to say is that what you learn in diploma as multiplexing, PCM multiplexing is only level 1 of the SS7 protocol. But there are a lot of other levels to study now in the advanced diploma. You see please, everything in the diploma is now MTP level 1. The syllabus has been designed in such a way that MTP level 1 you study in the diploma. But other levels we discuss now in the advanced diploma. So that's how you have to relate. We are not going to write that. When you are cramming later, you have to think like that. A lot of students find these areas troublesome to cram because they cram without having the overall picture in the mind. That's a good way to lose marks in the exam. We should have the overall picture in the mind. What did we study in the diploma? Why is certificate level? How are they getting connected to the overall picture? Likewise, you must have a mind map of everything when you are cramming. Otherwise, the cramming will be useless. Because what you cram will never come to your mind in the exam. You know what I mean, right? You have been facing exams and you have been facing situations where what you cram didn't come at that time, isn't it? Why? If you ask why, that is because we cram without having the overall picture in mind. So, especially when you do technical work in the company or anywhere, you must have the overall picture of the network you are maintaining or whatever that's in the mind. That is the ability of a good technical person. So, therefore, you have to train your mind a little bit for overall picture. When you are cramming, you use the technique. How do you train? Just imagine a place that you have been and then look at it from the top and see whether you can see the building. Example, this building. If you have the mind map of this whole temple and where this building is now, not from walking here. Everybody sees the building while walking here. But have you seen it from the top? The roofs and how these different buildings are in place from the top. So if you have not seen, you can go to our website. So maybe you have seen from the website the Google map has the roof, and you can see the different buildings from the top. That is the mind map. If you have that kind of a mind map about your syllabus, then you are good. You know what I mean, right? So you could see your home from the sun. You may see your home from the sun. Everybody sees. So it's not a special ability. Seeing it like this is not a special ability. And to see the other side of the home, you have to go this way and go this way and see. So if you are climbing like this, soon you will forget what you climbed. But before you start going for these details, this is what you should see. You should see, there is your home. Is there any road going by? Overall picture. After that, you focus on the details. That's the best way to study. If you have not been doing that, this side, that will definitely increase your score in the exam. That's why I always mention where is it linked to the diploma and how is the syllabus named, where are the applications. I am mentioning all that, but we are not writing all that. So later when you study only by the notes, you will be in trouble unless you remember what we discussed here. Because we are trying to discuss it from the top, relative to other subjects, application, lower level subjects, etc. But I am not giving a note on that. So some of you, I know, is just writing down here, thinking that that is the way to study. Then later, maybe next month or month after that, when the exam is closed, you start reading all that. Try to remember as much as possible. Try to do the past papers and go to the exam. And what do you get? Maximum simple part. Maximum. Because Italians do not expect only that, they expect you to see the big picture. See the relationship between what you study, lower level, higher level, etc. So, every lesson, now that you are at a higher level, every lesson look from the top and try to see this relationship. After that, go into the lesson and go for the details. It will make it easy to remember. That is why I mentioned that MTP level 1 is something you have studied. You have spent your whole diploma to study only this level 1, MTP level 1. And today we have to study level 2, level 3, etc. And I hope you remember that times of business we have been discussing in diploma. And maybe you might remember what is the duration of a frame. How long is a frame in level 1, MTP level 1?
125 microseconds.
125 microseconds. Some of you might not have remembered, and that is then that is not seeing the big picture. If you can remember the details like that, then you can fit things into the big picture. So that's why he got a D. He scored all D's in all subjects, so that is why. Overall integration idea. So learn the techniques. Not only the theory, but the techniques also. Then we all can score D's. If you are not scoring D's now, somewhere there is a problem. Internal problem, which you think is not your problem, it is because of something else. We always try to attach the problems to somebody else. If there is nobody to blame, we might sometimes blame either the president. He is causing all these problems, but actually who is causing? All the problems is caused by your own mind, not by anybody else. Understand that? Don't blame anyone. Don't blame the system also. Just identify that it is your mind trying to fool you. Okay, last time I mentioned you, isn't it? You have a feeling that your mind or the brain is the most wonderful organ in the body, isn't it? You believe that? If you think carefully, you will notice who is telling you this. Who is telling you that? The brain. Your brain is saying that okay, brain is the most wonderful. So it is trying to fool you all. That's why when we don't get marks, high enough marks, you blame city analysis. Sometimes the president of the Queen of UK, isn't it? Now that is the way your mind works. All our minds work like that. We always externalize our problem. You ask any psychiatrist, they say it's a mental problem. We externalize our problem. We think, okay, it is not me, it is someone there causing trouble to me. But it's your mind's way of fooling you. Your mind always says, look outside. That is where the problem is. It never says, look inside. This is where the problem is. It never says that. If you are smart, you will learn, okay, who is asking you to look outside? It is your mind. It is the one trying to fool you. Then you will overcome all these learning problems. The moment you start to see that, you know where the problem is. And you will find them and you can correct them. And otherwise, it's always either S or F in the exam. You can try, if not English, you can try other exams, still the same result. So those are the issues, right? Okay. Application correction, that is what I am saying now. Now the exam applications are coming, so you have to apply for the advanced diploma on the subject. But think of, have you got your techniques corrected? Have I corrected my technique? So am I going to do the same thing again? So therefore, mix the theory with the technique. Theory and the technique. Okay, coming back to this. MTP level 1, now we wrote a short note, but this includes everything in the diploma. Then we will move to the new thing, MTP level 2. Start covering MTP level 2. In the level 2, it is the data link level, isn't it? So earlier we wrote for level 1, you might now see we underline signaling digital link, isn't it? Now if you modify that word, what should we write now? For the level 2? Signaling data link. It's not a digital link, it's a data link. So you can write this is the signaling data link level. Signaling data link level. Signaling data link level. Underline signaling data link. It is a frame-based protocol. Frame-based protocol. Underline frame-based. The PDU, protocol data unit, is a frame. PDU is a frame. However, the frame is called the signal unit. Signal unit. Underline signal unit. You can get it SU. Signal unit or SU. So maybe you can write in the next line. This Q is the frame. In the OSI layers we call it the frame, but in the detector one we call it signal unit. is a message you have to remember. And SQs, there are several types of SQs. There is one called MSQ, LISQ, LFSQ. Likewise, different types of frames have been identified. Frame is SQ. Okay? 3 types. You can write there are 3 types of SQs. 3 types of SQs in level 2. Number 1, MSQ. MSQ means message signal. M means message. M is message. Message signal. Second one, LISQ. LISQ. Link status signal unit. Link status. Link status. LI means link status signal unit. And the third one is actually FISQ. It is correct. Third is FISQ. Earlier diagram can you correct? FISQ. FISQ. Fill in signal unit. Fill in. Length is 0 because it is length information. Length is 0. This is 1 or 2 bytes. This is long. Length is greater than 2 bytes. LI means length information. It is very short packet here. Only 1 or 2 bytes there. And large amount of information can be the MSQ. Message signal unit. So we will try to see the structure of the frame, structure of the signal unit. Okay. The structure of the SQ. The structure of a SQ is shown below. Structure of SQ is shown below. The second one, this is LSS. We will draw only this MSQ, we don't need to draw everything because this is the important one. Maybe you can put a star. That is what carries the message. The other things are basically controlled overhead. This MSQ, when you look at it, is like this. Similar to the Ethernet frame. There is a flag followed by the control field, followed by the length information field. That is one I showed you, length information. And I'm sorry, this is going together. There's nothing in between. Then SIO. SIF, this is the packet coming from the upper layer. The blue one is coming from the MTG level 3, which is encapsulated by this part and that part. Then CK means the check byte, which is similar to the frame check sequence in the Ethernet. Then ND flag F2. So again you can see this is very similar to the OSI layer 2 frame. What is the OSI layer 2 frame in general? We call it HDLV. HDLV. We studied it in the literature. No? So this is very similar to the HDL. And which is older, this one now HDL. HDLV was defined earlier in 1970. And the step 7 came into being in 1980. So this part has been defined little late, but they did not follow the OSI terminal. Instead of layers, they call it levels. Instead of frames, they call it signal units. And you can see lots of different word characteristics. However, the frame format, when you look at, format looks very similar. All the terms look different. Especially because this frame is heading this way, heading to the right, right? So put an arrow and mention that. Heading to the right. You should go another. Right. That is the front side. Frame is going into right hand side, not this side. And you don't need to do these. These are the details. And when you join, please join this gap, right? Because the gap can't be there. There's no gap there, I can mistake. Connection with new frame, and here itself you can write this frame. So then also we can mention frame. LI length information. That means how long will be this SI file. SIO means service information output. Service information offset, OCTET. Offset means the byte. Service information offset. So it will inform network details like whether it's a national call or international call, and also the user part information like ISUT or HTTP, signaling network management, etc. Those things will be going here. The SIF is the level 3 user information from the higher level. SIF stands for signaling information frame. Signaling information frame. Signaling information frame. In bracket from the upper layer. From the upper layer. If it is Ethernet, the upper layer one was the network layer. Here it is MPP3. So SIF is like the IP packet in the case of SIO model, Ethernet model. IP packet comes and then Ethernet frame will encapsulate that. So here we don't use the word IP, we call it SIF. Signaling information frame. Right? The next one, TK is check byte. TK check byte. Check byte. Everything like similar to XCS, frame check sequencing. Frame check sequence in HDLC. Frame check sequence in HDLC. Last one is again the flag, ending flag. This part you can bracket. You can bracket this part and call it header. From this point onwards it is a header. From this point onwards it is a trailer. The header and trailer you can indicate in the diagram. So the header and the trailer, they encapsulate the MPP level 3 PCB. Note the similarity with the HDLC protocol. Note the similarity with the HDLC frame. HDLC frame. Level 2, MPP level 2, carry out the following function. While you write this, let's read and see. Number 1, error control. Bracket using ARQ. I think you know that ARQ is automatic request for repeat. ARQ. Number 2, flow control. 3, supervision and maintenance. Maintenance information of the network. Number 4, framing. Number 5 addresses. So that's all about the level 2. NTT level 2. Then in the discussion about NTT level 3. NTT level 3. The name given to that is signaling network level. There is signaling digital links, then data links, then this is the signaling network level. Signaling network level protocol. Signaling network level protocol. And then signaling network level. Its main job is routing. Main job is routing in the signaling network. Routing in the signaling network between signaling points. Therefore, this is the packet level. This is the packet level protocol having packet switching. It should have logical addressing. It should have logical addressing. Underline logical addressing. Using brackets like IP. IP is also logical address. Physical address is the MAC address. So something similar to IP you must have, but they don't call it IP. They are not using the Internet protocol name. They are using NTT level 3. That's the name. So they call these addresses point codes, because signaling points are there in every exchange. Each signaling point is identified by a code, which is a 14-bit code. 14-bit code is given to each signaling point, and those codes are called point codes, CC. Because they are attached to the signaling point, they are called SPC, signaling point code. So instead of IP addresses, they use SPC. You can write. They use SPC. SPC, you can mention. SPC stands for signaling point code. SPC stands for signaling point code. Signaling point code. So each SP, each signaling point, each SP has a SPC. As a 14-bit SPC. Therefore, 14-bit SPC. Therefore, NTP level 3 PDU, NTP level 3 PDU carries a 14-bit DPC, destination point code, 14-bit destination point code, 14-bit DPC, and a 14-bit OPC, 14-bit OPC. Originating point code, OPC originating point code. Underline DPC, underline OPC. But both are point codes. But you know, when you send a packet, you must have destination address and source address. Like an IP kite has destination IP address and source IP address. Same way you have destination point code and originating point. Name is different, but method is the same. If you separately gram SS7, it will be difficult, but if you compare with ISO stack or the IP stack and gram, there will be lots of similarities and very little things you have to remember. Right? Okay. We'll write down the 14-bit code. This is the 14-bit code. First 3 bits will identify the zone, next 8 bits area of the network, next 3 bits signaling point. So this is like an IP address. Using this address, these packets can travel anywhere in the world and they connect this connected to any exchange in the network, in the world. Any exchange in the world. The number of exchanges in the world are less than number of people. Therefore, IP address needs to be long. IP addresses are given people, organizations, everywhere. But this need not be that long. Why? The number of exchanges are not that many. And this is a worldwide address. But not unique to the whole world. I will explain how. So this is a two-layer addressing scheme. Not like IP. I'll come into that. First you can do this. Go ahead with green format and call it format for international SPC, international signaling point code. You can study all these numbering plans in that web as well. Signaling point code. This is the two-level. This is a two-level addressing scheme. Namely international level and national level. Namely international level and national level. Therefore, XP is duplicate in each level and duplicate in each level if necessary. If necessary. In addition, there is a 4-bit signaling link selection code. Signaling link selection code. Generated SLS code needed for routing. SS7 signaling message needed for routing. SS7 signaling message. This is the idea of two-level scheme. You don't need to write the information, just draw 2 layers like that. The international layer is only one layer. All countries joining. These are countries. This may be India, this may be Sri Lanka, like that. So in Sri Lanka, you can use SPC equal to 277. International also 277 is there. But because they are 2 layers, there is no problem. This is the international code and national code. So you can just show that numbers can duplicate in the 2-level scheme. There can be same SPC number at the international level, but it will not make a mess. It will not divert to the wrong place. Earlier we studied this SIO. Inside the SIO, it will mention whether the code here is national level or international level. So you can tell national level packet to the same code without changing the international level. It doesn't make a problem with the addressing. Although SPC has a duplicate number. Because level has been identified in the SIO. You don't need to go this, just mention this. SIO level indicates whether it's a national or international. This one you don't need to go again. You go it. we have written short notes for level 1, 2, 3. Next we will discuss about this one, ISUT. After we finish that, we will come to discuss ISUT. One last sentence is right over. The floating bit DPC destination point code will be used to route the packet. Packet is in bracket SI here. Packet is known as SI here. Packet through STC, but STC signaling transfer point. They are the routers. Through STC signaling transfer point up to the destination SP, destination signaling point. So the idea, we can just show this again, that there is a signaling point with the exchange. There is a signaling point within database also. STPs are the routers. In English these are called routers, but in SS7 we call them STP. The idea, it has routing actually. between exchange, between one exchange and the user, it is ISUP. And on this link, it is MAC protocol, application protocol work. The yellow one, the same color what you said, yellow is for application layer. It is for lower layers like routing layer. They don't call it routing, they call it relay. Again the name is different. The office actually routing. Signaling transfer point, STP. STP is relay, signaling messages until they reach the destination. Submitting ISDN user file. It is the fourth level of the protocol stack. In the Internet protocol, TCP/IP stack, what is the fourth layer called? We call it application layer. And here also it is application layer, but the protocol involved is one. It is called the ISUP. This is for circuit switching. Right? That means every time you take a telephone call, it is using ISUP. But you may not be using ISDN phone. Right? ISUP is not for ISDN phone. ISUP is for all circuit switch connections. So whatever your phone is, it is using ISUP. Suppose you take a call from your phone, say mobile phone to a fixed network. Mobile phone to the fixed network, still it is the same. Mobile phone to mobile phone, still it is the same, etc. So you need not confuse this with the ISDN phone. Right? ISDN phones are completely different things. This ISDN user part is a protocol used for setting up all the calls in the world. All the calls in the world. Any voice call, because it's circuit switch, is set up by this. But if it is a packet switch voice call like VoIP, voice over IP, then you use something called SIC, SIP protocol. It is different to SSL. Unless it is VoIP, all other calls, whether it's a mobile call or a SIP call or ISDN or whatever, it is always ISDN. So sometimes you may confuse that ISDN name has come here, that means it is only for ISDN calls. But don't confuse, it is not only for ISDN. Right? All your telephone calls are set up by this one. This is used for establishing and terminating circuit switch connection. Connections within bracket false. This means basically false, right? Therefore, it is one of the most used protocols protocol. Filter. However, it cannot be used between an exchange and a database. It cannot be used between an exchange and a database. That is a standalone database. Exchange and a standalone database. If the database is inside an exchange, you can connect. But suppose database is standing alone separately, you can't connect. You need HTTP as a protocol. Standalone database. It can connect between exchanges. Therefore, ISQP is generally used in the PSTN. At this moment, structure, you can just show this. This is application side, and this one is the lower level, lower stage. Don't know this stuff. This is the structure of ISQP message. So ISQP message. First one is PIC. 2 octets, 2 bytes. But this is not mandatory, this is also mandatory. Mandatory fixed part, mandatory variable part, then an optional part. Give an example of this message type. Example is IAM message. There are the IAM is one type. Mandatory variable part, you must have the called party number. Who is calling whom must be there in this part. So if you catch an ISQP packet, you can find out who is trying to set up a call with who. Still the call is not set up yet. You are requesting the exchanges to set it up. How is the billing done by the telephone exchanges? The billing is done by these ISQP messages. By exchanging messages like this, the exchanges will decide, okay, we set up a call now. And from that point onwards, the billing starts. Therefore, ISQP is directly related with billing also. But what you feel is that somebody is ringing you, isn't it? Your phone will ring. But before that, the ISQP messages were sent from that exchange all the way to signaling transfer point. The link setup message will come to your exchange, and your exchange will acknowledge that. Okay, I got it. While you are being informed that you will be ranked by the exchange after that request has been confirmed. So those things happen before your phone ring. Before the phone ring. And the moment you answer, there will be another ISUP message to the other side confirming, okay, he answered this moment. And that is the start for billing. So now you can see ISUP is heavily used protocol. Every time a person calls another person, everything is set up by ISUP. After the call, after you hang up, the two exchanges again exchange ISUP messages to say, okay, that circuit is now over, we will use that circuit for any other use. So lots of ISUP messages are going in the SS7, in the signaling network to set up calls. How do they set up calls between a mobile network and a fixed network? The mobile network works with a differentiator, the fixed network works with a differentiator, but a customer from a fixed network can call a mobile network. How can we do this? Because of ISUP. Both networks understand SS7. SS7 is a common protocol. So SS7 requests come from, say, SLT network to your mobile operator's network. It is ISUP packet coming, and your network understands it. And then only you will be paid. And when you answer, it will be confirmed to the other side. Otherwise, this is not possible. Two different, completely different theories. How can one person call a mobile network? It is because of this protocol. Now you can see the usage or usability of this theory. Heavily used theory. You can mention. You can also mention CIC means CIC, Circuit Identification Code. CIC, Circuit Identification Code. It contains time slot. Time slot number of the TDM frame. Contains the time slot number of the TDM frame. Time slot number of the TDM frame. Of the circuit to which the ISUP message is associated. Of the circuit to which the ISUP message is associated. ISUP message is associated. Circuit means the time slot. So the time slot number. What is the time slot number we will assign to this call? The two exchanges will have to agree. So the request will go with the time slot number. So let us draw this diagram only, don't write anything. Let's draw the diagram. We will have assume, for example, there is a circuit like this. Circuit means there is a time slot. Then this exchange will have to send the message to this exchange through the signaling transfer point requesting this circuit. The other party will have to agree. Then only the circuit will be open for the user. Circuit means time slot, right? Circuit means time slot. Let's select the link. PIC selects the time slot in the link. Select the link because there are many links. Therefore, SLS is needed to identify which link. PIC needs to identify which time slot in that link. So you may simply say SLS identify the link. SLS identify the link and PIC identify the time slot. PIC identify the time slot. Maybe we should do an example to understand this whole thing. Right? So we'll see an example where three exchanges pass the message. Right? Assume that this exchange has SPC of 82, or code is 82. This exchange 22, national level, right? National level 60, likewise every exchange in the whole country has a SPC value. That is SPC signaling point code, which is the exchange number. And then each exchange will have different signaling links. Only one link is needed now. There are many other links, signaling links, to the signaling network. The signaling link is 4. I have selected signaling link 4. And signaling link 7 of this STP will be connected to this text. Likewise, all these signaling links there at the signaling network have a number. That is called the link now. That is the SLS. SLS is a 4-bit code. Then time slot is a 16-bit code. Circuit coding means time slot coding. In this link, time slot number 14, I am requesting. So this is the message I have to originate. ISTP message. This exchange will originate a message saying, okay, my name is 82. Originating point code is 82. That's my name. I am the exchange. I am originating. And I am sending this to exchange number 22. 22 is there. Exchange 22. And I am requesting on link 4 and circuit 14. This is this time slot 14. This is the even line. There are many time slots. I am requesting 14. Okay. So then with that the message will go, get routed, then 5 bits will come here. This exchange will understand, okay, he is requesting time slot 4. And there will be a reply. Likewise, it will go on. Shall we draw the key idea? It is a similar one, exchange 22 requesting 60. Another circuit number 20 being requested. So likewise, when you take a call, suppose you call your friend from your exchange, one circuit is required. From this exchange to this exchange, another time slot is required. Many time slots like that will have to be reserved in very quick time. And by the time you hear ringing, all these time slots have been assigned. You can see how fast it is happening. Right? Please combine your knowledge with the time slots, about the time slots in the diploma with this now. No? why we can't allow any other traffic to come into this network. Suppose it is something like internet and any different types of audio, video, various traffic go in the internet through the router, therefore sometimes slow. But for these ones we can't allow any other traffic, only signal, right? Otherwise your call setup will slow down. Nowadays you find when you just dial a number within a short period the call is set up. Because this network, with these types of routers or relays, get only those short requests only. They don't handle anything else. They don't handle audio video. They are only handling signaling. Signaling messages are short. So that is why it happens fast. But sometimes in the internet, sometimes certain websites will be very slow to download. Right? It slow down because of various bottlenecks in the middle, because it allows a variety of traffic to go through. But this does not allow variety of traffic. This allows only signaling request, that kind of traffic to go through. So this one is now requesting a circuit number 20 from the next one. So like this is continuous. This is the transit exchange. Transit means middle exchange. It receives this message called IAM message. It contains the beep number, and the exchange performs number analysis. Number analysis is not part of the ISUP, it is something internal to it. And then it selects a new DPC, and again ISUP will carry that message to the next one. Likewise it will go very quickly. Remember, this happens lightning fast because there is no other traffic other than this request, all request. IAM, I will explain the IAM messages, format I will explain. Did you notice another difference between the internet and the internet? This number analysis is done by the router. The router will analyze, and then there is a routing protocol which decides which route to be chosen. But here, message comes here. Signaling network job is to deliver the message here. Exchange will do the number analysis and then decide it has to go to 60. It is not the STP deciding. Exchange will decide. After that, exchange will make another reference to the signaling. So that's another difference. This is not between the internet and between the internet. The routers are intelligent, very intelligent, and they will do routing calculation. But here, full routing calculation is not done by the STP. Partly done by exchange itself. Partly done by the exchange itself. Okay, so this example is, I think, self-explaining basically how two-hop call connection is made. We will have a short break there, and after that we will continue to discuss on this IAM message and the ISU.